List everything you can include about parallelogram based on the rotation of a triangle on the midpoint of the sides. So the first thing we talked about, parallelograms have pairs of opposite sides are parallel. That means that segment AB or side AB is parallel to A prime C. And we put the little parallel mark on the figure. And that BA prime, segment BA prime, is also parallel to segment AC. And to show that those are parallel, we put the little parallel marks, but we double them so we know that these two are parallel to each other. Okay. We always want to mark the figure. Okay, then our next one is opposite sides are congruent. Since these triangles are just the same triangle rotated around its midpoint, okay, that means this side is going to be parallel to this side. Not parallel, congruent. This side is going to be congruent to this side, and this side is going to be congruent to this side. So it'd say that BA prime, segment BA prime, is congruent to segment AC. So this is congruent to this. And we put the congruency mark on those line segments. And segment AB is congruent to segment A prime C. So this is congruent to this. Any questions over that? Now we need to talk about angles. What angles are congruent in here? Anyone have an idea? Do you have some? What angles look congruent here? Yeah? Angle B and angle C. Okay, we want to have the bigger angles. So this angle here, this whole angle, and this whole angle. Okay, so that would be opposite angles are congruent in parallelograms. So that would be angle A, BA prime is congruent to angle A, CA prime. And angle A is congruent to angle A prime. Because if you remember, we have the green matching the green up here, so those two angles are the same angle after I rotated my triangle. And this is red and blue, and this one's red and blue, so those two angles are also congruent because of my transformation of my triangle. So then we would also put the arc marks on the A and the A prime to show that those two are congruent to each other. Any questions over that? The next one would be Consecutive angles. Consecutive angles are, any idea? Like angle A and angle AB, A prime. How would those be related? What? They're not congruent, obviously, right? One's an acute angle, one's an obtuse angle, so they can't be congruent. They add to 180. They're supplementary. Okay, consecutive angles are supplementary. And we can see that because we have this angle here that's green, and the red and the blue together form that straight line. And straight angles are 180 degrees. So this green and this red and blue together, they have to also add up to the 180 that all three of those add up to. Does that make sense? Okay, so we'd say the measure of angle A plus the measure of angle AB, A prime equals 180. And we could do this like 10 times. So now we're going to do the next one. Angle AB, A prime is also supplementary to angle A prime. So the measure of angle AB, A prime plus the measure of angle A prime equals 180. Any questions over that? We'll go keep going. A prime and then A prime CA are also supplementary. Measure of angle A prime plus the measure of angle A prime CA equals 180. And then there's one more. The measure of angle A prime CA plus the measure of angle A equals 180. Any questions over that? Okay, the fifth one, consecutive angles are supplementary. Opposite sides are congruent, opposite angles are congruent. Okay. We have diagonals. They're diagonals. Bisect each other. So in our figures, you're only showing one diagonal, but if we connect A to A prime, we get our other diagonal. And I'm going to label this point P right here, just in the middle. So that would be, this part is congruent to this part. And this segment is congruent to this segment. So we would say that segment BP is congruent to segment PC. And segment AP is congruent to segment PA prime. So from A to P is equal to P to A prime. Any questions over that? Okay, the last one is that Okay, parallelograms are created through combining congruent triangles or by rotating a triangle about one of its sides midpoint. So they have congruent triangles as part of them. So in this one, we would see this top triangle of BA prime C is congruent to the bottom triangle of BAC. Does that make sense? So it's a triangle. B A prime C is congruent to triangle. Okay, when I rotate my triangle, what corresponds to this B, if we look here, it's the blue one here, is this blue one over here, which would be C. Does that make sense? To triangle C, what corresponds to A prime is A. And what corresponds to the C would be the A, is the B, sorry, is my B. Does that make sense? You need to make sure you match up the angles with their corresponding congruent angle. Any questions over that? Okay. Now rectangles. Rectangles are parallelograms. Does anyone know how I know if something's a rectangle? 4 sides and 4 right angles. Okay, so it's a parallelogram. Okay. Rectangles are parallelograms. With 4 right angles. Okay, that's what a rectangle is. So all 4 of those have to have right angles. Okay. Then a property of a rectangle that's different than just a parallelogram. Okay, all parallelograms have these 5 things. Okay. Rectangles have a special thing about the diagonals. Okay, the diagonals of a rectangle are congruent. That means triangle, not triangle. What am I saying? Segment BD is congruent to segment CA. Segment BD is congruent to segment CA. Those 2 diagonals are congruent to each other. What is the other thing I know about diagonals of all parallelograms? Can someone raise their hand and remind me? Just read what we just wrote. What all others? Yes. They bisect each other. So we also need to know that. Okay? The diagonals of these also bisect each other. That means that this is congruent to this, and this is congruent to this. In rectangles case, that means since the diagonals are congruent to each other, all the little pieces are congruent to each other. Does that make sense? So they're telling me that BD is 40. So from here to here is 40. And then MC, so from here to here, or sorry, MC from here to here is 3x plus 4. Write it down. We're all good? Okay, so anyone have an idea of how I can set up an equation so I can find x? Anyone have an idea of how we can set up the equation? How would MC, so we already said this, that MC equals AM, sorry, it's congruent to AM. And we said that BD, segment BD, is congruent to AC. But we also said that all these little pieces are congruent to each other. So how is MC related to BD? Okay, so segments, lengths of sides are not going to have anything to do with our angle degrees of 180 or 360 degrees. Okay, those are purely angles. Now we're dealing with segments. Not questioning. So we can say that BD is equal to, not 1/2, sorry, let's do that. Let's fix that. That MC is equal, the measure of MC is equal to 1/2 the measure of BD. Because it's just halfway across, right? And since BD and AC are congruent, MC is going to equal 1/2 of BD. Okay. And our reasoning is because diagonals of rectangles are congruent and bisect each other. Any questions over that? Diagonals of rectangles are congruent and bisect each other. So we need both of those for this problem. So we have MC, which is 3x plus 4, equals 1/2 of BD, which is 40. So then we're just going to solve. 3x plus 4 equals 20. Subtract 4, get 3x equals 16. Then I'm going to divide by 3. I'm going to get x equals 3 divided by 16. 3 and 16 5 times. 3 can go into 10. Bring my decimal up 3 times. And it's just going to keep repeating. So it's going to give me x equals 5.3 with a line above it, units. Any questions over that? We're all good? Okay. Okay, I want you guys to do A in your pairs. Look back at the properties of parallelograms to come up with all the different missing angles. And don't forget to explain your reasoning. Tell me why. Okay, we're back up here. Okay, Ramiz, give me one of the angles that you found. Okay, what angle was 121? B, C, or D? Angle C was 121. And why? How did you get 121? Okay, consecutive angles are supplementary. And parallelograms are supplementary. Okay. And then let's see another angle. Ethan Olson, what's another angle? 59. Which angle is that? Okay, the measure of angle D is 59 degrees. And why? Because opposite angles are congruent. Very good. Opposite angles are congruent in parallelograms. So this is also 59 degrees. That also makes this one 121 degrees. Shh. Any questions over that? Okay, so our next one. Find the measure of angle BCD. So here's B, here's C, here's D. So find the measure of this angle here. There's a couple different ways we can do this. I'm going to put an X there so we know it's X. Any idea how I can find that? Yep. Very good. So I can do 79 plus 35 plus X equals 180. Because this angle and this whole angle together are supplementary because they're consecutive angles in a parallelogram. So then we're going to combine our like terms. And that's going to give me 114. Is that right when I add those two? I'm going to subtract 114. That's going to give me X equals 66 degrees. Okay, and our reasoning for that was consecutive angles in parallelograms are supplementary. Any questions over that? We're all good? Okay, next one. Let's have you guys do that in your pairs. Find not just X, you guys, look at, find BA. You have to find X first, and then you have to find BA. Shh. Quiet down, please. Most of you came up with those were congruent. Oopsie, let's spell better. Opposite sides of parallelograms are congruent. That's our reasoning. So I'm going to have 5x minus 3 equal 4x plus 12. I'm going to move my x's over here. And I'm going to move my 3 over. That's going to give me x equals 15. But then I have to plug it in. I have to take this and plug it into BA. So I'm going to get BA equals 5 times 15 and then minus 3. So I'm going to get BA equals 75 minus 3. So the measure of BA equals 72. Any questions over that? We're all good? Okay, next one. Okay, BC is 16. So this right here is 16. EC, this part right here, is 2x minus 4. Celeste, what do I know about diagonals and parallelograms? Let's go back and look. Diagonal parallelograms. They bisect each other. So I have two congruent pieces. So that means that BE, segment BE is congruent to segment EC. And EC then is going to equal half of the whole of BC. And that is diagonals in parallelograms bisect each other. Any questions over that? Okay, so I can just plug it in. So EC is 2x minus 4, and it equals 1/2 of 16. Any questions over that? So we're going to solve 2x minus 4 equals 8. I'm going to add 4 to both sides. I'm going to get 2x equals 12. Divide by 2, divide by 2. I get x equals 6. Any questions over that? Okay, the next one. Find BE. 9. I don't know what I was thinking when I made this, but I don't know. Yeah, it's 9. Yes, it didn't ask me for n, it just asked me to find BE. I should have asked to find n, but you know. Okay, in parallelogram WXYZ, measure of angle W is 50 degrees more than the measure of angle X. sketch parallelogram WXYZ and find the measure of each interior angle, then label each angle with its measurement. Okay, so let's start by sketching it. Okay, let's sketch a parallelogram. And then we're going to label it W, X, Y, Z. Super easy. Then we want to know that the measure of angle W is 50 more than X. In math, what does the words more than mean? What operation would be more than? Adding. More than means I'm adding. Less than would mean I'm subtracting. Doubling would be multiplying. Half would be dividing. Okay, those are words and how you translate them into math. So do I know X? They're giving me my X because I don't know what it is. So the measure of angle X is my unknown, so I'm going to put an X there. I do know that W, though, is 50 more, so I have to add X plus 50 for W. So then I could also say that Z was X, and that Y would be X plus 50. Oopsie, where'd it go? And we want to find the measure of each interior angle. Anyone know how I'm going to set up my equation here? Okay, X plus 50 plus X plus 50. Okay, Desiree, what do I know about my angles in a parallelogram? I have two things about them. Numbers 3 and number 4. Angles. 3 and 4. And supplementary. Okay, so how can I write an equation here? So let's call Leilani, how can I write an equation? Okay, that'll work. So she's saying that all of my angles should equal 360, right? So we can do X plus 50 plus X plus X plus 50 plus X equals 360. We can do it another way too. If you had, right, because we also had the other theorem, or not theorem, property here would be that consecutive angles add to 180. So I could have just used two of my angles instead of equal to 180, but this will work as well. So I'm going to combine my like terms. X plus X plus X plus X is 4 X's. And 50 plus 50 is 100. And that equals 360. I'm going to subtract 100. I'm going to get 4X equals 260. Divide by 4, divide by 4, and I get X equaling. That's 4 can go into 26 6 times with 2 left over. 65. Is that right? Okay, check my math, you guys. So X is 65 degrees. So the measure of angle X equals 65 degrees. That would also mean the measure of angle Z is equal to 65 degrees. Then we would have the measure of angle W equals 65 plus 50, which is 115. And that would also mean the measure of angle Y would also be that. Any questions over that? Now we set up our equation based on the fact that all parallelograms, the sum of the interior angles of a parallelogram equals 360. So that's what we're going to use here. Okay. That would be our reasoning why in this case. Any questions over that? Yes. Then that would be consecutive interior angles of a parallelogram equal 1 or supplementary. Okay. Either way will work. You just have to have a different reasoning. Okay, we're not going to do the last example. You guys have your homework. Okay, I'm going to have you guys work on that for a few minutes right now. What's due today, you guys? THQ by 8 p.m. Okay, this is due on Friday, but you will also have your review for your test. So right now you're working either your THQ or your homework.